Hello there. In this video we're going to do a finite difference problem. I have the table in front of me, and first thing we're going to do is figure out the first difference, and to do this we're always going to do right minus left. So in this case it's 7 minus 13, that's negative 6, and then 3 minus 7, that's negative 4, and so on and so forth. So those are the first differences. Then we're going to do that process again. And once again, we're going to do right minus left, so this is negative 4 minus a negative 6, or negative 4 plus 6 to be 2. Right minus left, 4 minus a negative 4, and that's 4 plus 4 is 8. Right minus left, that's going to be 14, and so on. So that's the second difference. Last one, we're going to do the third difference. Again, right minus left, 8 minus 2, that's 6. 14 minus 8, that's 6, and actually all of these are 6s. So, because this is the stage at which it stabilizes, that means that it's going to be, and that's the third difference, that means that this is going to be a polynomial and it's going to be cubic. Because it stabilized at the third difference, so the highest power this polynomial is going to have is going to be 3. So it's cubic, it's of some kind of form, ax cubed plus bx squared plus cx plus d. And we're going to try to figure out what a, b, c, and d are. And the way that we're going to do that is look up here, and we're going to write an equation. So when the input is 0, the output's going to be 13. So sticking in a 0, a times 0 cubed, b plus b 0 squared plus c times 0 plus d, all that's going to have to spit out a 13. And then I can do that for any one of these other ones, so we'll do that also. We've done that here, we'll do it here, here, and here. We have 4 unknowns, a, b, c, and d, so I'm going to need 4 equations. Sticking in a 1, I get that, and sticking in these other things, I get this stuff. Now, generally, I don't write this whole part here. This is just helping me get the whole expansion for everything. But what we're going to see here is we're going to create a matrix equation with these coefficients. So the leading coefficient of that a, that's going to be 0, 0, 0, 1. Then I got 1 cubed, that's 1. So the next one's just a whole bunch of 1s. 2 cubed is 8. 2 to the squared is 4. Then I got 2, and then I got 1. And 3 cubed is 27. 3 squared is 9. There's a 3 and there's a 1. So this is my coefficient matrix being multiplied by the variable matrix a, b, c, and d. And that's going to spit out the resulting matrix of 13, 7, 3, and 7. So if I try to ask, like, how is this 3 generated? That's row 3, column 1, so that's going to be this times this, 8 times a, 4 times b, 2 times c, 1 times d. That's exactly what this equation here is giving me. So that's where these numbers in that coefficient matrix are coming from. Okay, so now we're going to try to solve this. Well, multiply by the inverse matrix to get to the other side. And we wind up getting that a is 1, b is negative 2, c is negative 5, and d is 13. So that means that our whole equation for this thing is going to be f of x is equal to a, which is 1, so a is 1, x cubed, plus a negative 2, so I'm going to write that as minus 2x squared, plus negative 5, so minus 5x plus 13. And we can always know if this is right or not, because we can plug it back into the equation and see if it produces these points. Okay, I just did that. It does hit all these points exactly, and that's how we can figure out the equation from a finite difference table. Character and Scholarship for Life.